So we're going to talk today about law of cosines. And it's similar to law of sines yesterday in that we're going to be still using a trig function to help us set this up. The formula does look a little bit different for law of cosines. Law of sines, if you remember from yesterday, you were setting up like proportions. And then you were setting them equal and cross multiplying to solve them. Cosines is a little bit different in just how it gets set up. Again, if we look at this chart, there's three different equations that they're giving you here, and the only reason why they're giving you three is because based off of the information that they give you in the triangle can change how you maybe want to set this up. Again, when you guys use law of cosines, you're only going to do this one time. You're only going to set up an equation one way. You're not going to have to do three of them. This just gives you all of the cases, whether you're looking at angle A, angle B, or angle C on a triangle. So what you're going to do, like if you were trying to find the measurement of side A. So on this triangle, that would be where little a is at. If I was trying to find the measurement of that side, I would use the first equation, which says a squared equals those two sides, b squared plus c squared, those other two sides there, minus 2 times that b and c side again, and then cosine of the angle A. So again, across from that side that we're looking for. The key here is that if you're looking for a side, you're going to have to use the angle across from that side. Just like law of sines yesterday, we were setting up angles in the sides that were across from each other in the picture. You do the same thing with law of cosines. The minus 2, that's going to be in all of the equations every single time. It's just in there. It's just part of the equation. That's what kind of helps make this thing work. So we're going to practice using law of cosines, but there will be cases where sometimes we start a problem out using law of cosines, and then we'll switch back to using law of sines, only because law of sines is a little bit faster than law of cosines. But there's cases where you're given a triangle and you can't use law of sines because you don't have enough information given to you. So you have to start with law of cosines first. So we're going to solve some triangles. We're going to round angles to the nearest whole number, and we're going to round sides to the nearest tenth. So just like what we were doing yesterday. So for this first one, they give us this triangle ABC. They say that side B, so little b is equal to 10.2. Side C is equal to 9.3. And the measure of angle A is 26. So I'm just labeling some of my information with what I have here. So I need to find a couple of things. So again, I'm going to start by kind of making just a little chart of what am I missing. Okay, so I'm missing two angles. I'm missing angle B and I'm missing angle C. And I'm also missing side A. All right, so all I've done so far is I've labeled my triangle with the information that the problem gave me. And I've created my box that has what I'm missing from the problem. Okay, so now what I'm going to do is try to start solving some stuff. So I'm going to begin by using law of cosines, because if I am trying to find A, little a, I have the angle across from it, which is the 26 degrees, and I have these two sides on either side of that angle, the 10.2 and the 9.3. So that's like my B and my C. It's basically using that very first equation up in that box from above. That one said that A squared is equal to B squared plus C squared minus 2 BC cosine of A. So I'm just using that first equation from up above. I'm just going to plug in the stuff that I know now, so I can plug in what I know for B and for C and for capital A. So I'm still going to have A squared. In for B, I'm going to put that 10.2. We're squaring that. And then I'm going to put in C, so 9.3. Again, that's being squared. And then we have minus 2 times B, which is 10.2, times C, which is 9.3. And then it has cosine of A, so that would be cosine of 26. Now, for law of cosines, because there's a lot going on here, it might be wise to break this apart into smaller steps. You can type that all in one sentence if you want. I would highly encourage you to be using parentheses. Okay, so if you see parentheses up here in my problem, that's where I would be putting parentheses in your calculator if you're going to type it all in as one sentence. If you're more comfortable with squaring things first and like doing the multiplication at the end just to kind of break it into smaller chunks, you can do that too, especially if you think that you're going to make a mistake. Okay, so if you think that it's easy to make a mistake by typing it in one big sentence in your calculator, then I would break it apart into smaller pieces. So I would take like 10.2 and square that. So that's 104.04. Then I would take 9.3 and square that, which is 86.49. Then I'm going to take 2, so I'm just going to bring that minus sign down. So I can take positive 2 times 10.2 times 9.3 times the cosine of 26. That's just one multiplication problem there. So that's 170.52 if I round. Okay, again, you don't have to break it apart like that. You can just type this all in. Just make sure that you're maybe putting parentheses around things so your calculator reads it correctly. So then I'm just going to add these first two numbers and subtract. So I get a squared equals 20.01. Now I need to find a, and I have a squared. So how do I get rid of something that's squared? Good, square root. So we're going to square root both sides. And we're going to round because it's a side to the nearest tenth. So I get 4.5 because it's 4.47. So if I round that to the nearest tenth, it would round up to 4.5. So that's side A. So now that I know side A up here in my triangle, so I could label this as 4.5 now. I still need to find those other two angles, B and C. What I'm going to do for this one is I'm going to switch now back to law of sines to help me solve for one of the angles. So remember, law of sines from yesterday was setting up proportions. Okay, so you take the sine of an angle and then you put that over the side across from it. And you set that equal to another sine of an angle in the side across from that one. So I have all of my sides up here. So I just need to pick one of them, either B or C, that I want to solve for. And I do want to use A because I have the measurement for the angle of A, and now I know the side of A because we just solved for that. So I'm going to do sine of 26 and I'm going to put that over the 4.5. And I'm going to set this equal to, let's just solve for B. So I'm going to do sine of B over the side across from B, which is little b, which they told me was 10.2. So I'm going to cross multiply. So we have 4.5 times the sine of B equals, I'm going to go ahead and take the sine of 26 times 10.2. And I'm going to round that. That's going to come out to be 4.5. Hang on a second. I'm not going to multiply that just yet because it's not going to get, if I'm rounding, it's not going to give me the correct answer. So I'm going to leave this as 10.2 times the sine of 26. So I need to get that b by itself. So I'm going to divide both sides by the 4.5. So now I have my sine of b all alone. And then I have this equation over here. I have 10.2 times the sine of 26 divided by 4.5. Now, because I'm trying to find an angle, think about when we started our trig functions in the first half of chapter 10. When you were finding an angle, that's when you had to use your inverse function. So you had to do sine to the -1, cosine to the -1 to find an angle. So that's what we need to do here. To find b, we actually need to do the inverse function. So we have to take sine to the -1 of this fraction here. That 10.2 times sine of 26 over 4.5. So what I would suggest to you to make your calculating easier, I would do the 10.2 times the sine of 26. So I'm just going to multiply those. Then I would divide that by 4.5. So you're going to take that decimal and divide by 4.5. When you do that, you get 0.9936412661. We have to do the second sign of that number. So you're going to do second sign, so it's the sine inverse, sine -1, and then that decimal. Now you can either round the decimal out a couple places. I would not round it to 1 because otherwise it's going to give you 90 degrees, and that angle's not 90 degrees. So I would either kind of round out that decimal a little bit, like do 0.994 maybe, or a lot of your calculators are programmed that if you hit your second key and then around like the equal sign, you'll see letters above a button that say ANS. That stands for answer. So it'll actually take your previous answer for you and plug it into the calculator. And if you're not sure where that is, I can show you later. But either way, if you take the sine inverse, whether you round or you use the actual decimal, you should get a similar degree to me, because we have to round this to a whole number. So I got 83.5 when I put in the whole decimal, and I got 83.7 when I put in the rounded 0.994. Okay, either way, they're both going to round up to 84 degrees, because I got 83.5 or 83.7. Both of those cause it to round up. So angle B is going to be 84 degrees. So then for C, now that I know 2 out of the 3 angles, and we know that triangles have to add up to 180 degrees, I'm going to take 180 and subtract 26 and 84 to get my angle C. And that's going to come out to be 70 degrees. Okay, let's take a look at another one here together. So this time they have everything labeled for us already on the triangle. And they give me all 3 sides. They don't give me any angles at all. So I need to find the measurement of all 3 of these angles. I need to know how much angle R is, how much angle S is, and how much angle T is. If I try to use law of sines, it's not going to work, because I would have like the sine of R over 3 equals the sine of S over 6.1. I have 2 variables there. Because I don't know any of my angles, I can't start by using law of sines, because you'd have 2 missing pieces on all of the fractions. So we have to start by using law of cosines. So in this case, X is the angle. So if you think about like your equation from up above, this one that we just used, in this case, the 3 is like where the little a would be. The 4.5 could be your B, and the 6.1 could be your C. And where X is at, that's where capital A is. So I'm going to have to write this one a little bit differently in my equation because I know the sides, I don't know that angle. So in for little a, I'm going to put that 3, so it's going to be 3 squared. In for B, I said I did 4.5. For C, I did 6.1. And then minus 2 times 4.5 times 6.1. And then cosine, I'm going to go ahead and just call it R. I'm going to ignore the X for now. Because you're missing the angle on this one, you cannot type this all in as one big equation like we were able to do on the last one. Because on the last one up here, when we were able to plug in this portion, because I didn't have any variables over here. Everything had a number that I was able to type into my calculator. Now I can't do that on this one because my variable is that R, which is at the very end. So I need to get that cosine R by itself. So we're going to have to move some stuff around here. I would suggest that you multiply what you can and then start moving stuff over. So 3 squared is 9. 4.5 squared is 20.25. 6.1 squared is 37.21. So you're going to have minus 37.21. Then I'm going to take, so minus 2 times 4.5 times 6.1. So that's 54.9. But that still has the cosine R attached. I'm going to take these two things here, the 20.25, and I'm going to subtract the 37.21 from it. Oh, we are supposed to add them. Yep, you're right. So I'm going to add them instead. There should be a plus sign there. So it'd be 9 equals 57.46. And then we still have minus 54.9 cosine of R. I can't subtract the 57.46 and that 54.9 because that 54.9 has the cosine attached to it. So it's kind of acting like that X right now. If they both don't have the same variable attached, you can't combine them. It's like trying to combine like terms. So I'm going to move this 57.46 over by subtracting it from 9. So you're going to get a negative number here, and that's normal. 9 minus 57.46 is going to be negative 48.46. And then that's equal to this negative 54.9 cosine R. So to get cosine R by itself, you have to get rid of that negative 54.9. Right now they're being multiplied, so the opposite of multiplication is to divide it. So we're going to divide both sides by that negative 54.9. This is going to cause that number to become positive again, because a negative divided by negative is going to give you a positive. So negative 48.46 divided by negative 54.9 is positive point, I'm going to round 883, and that's equal to cosine of R. So to find R, because we're dealing with an angle here, we have to do the inverse of cosine. So we're going to do cosine to the negative 1. We're going to type in that decimal, 0.883. And we're going to round this to the nearest whole number. So when you do second cosine to get your inverse and you type in 0.883, you guys should get 27.99. How would I round that? If it's 27.99, it would round to what? Good, 28. So R is going to be 28 degrees. Now that I have that angle, I can switch gears now and go to law of sines to help me find another angle, just like what we did on that last problem. So I'm going to do that over here on the far right side of the screen. So I'm going to set this up. I have to use that 28 because that's the only angle I know. So I'm going to do sine of that 28, and that's across from 3. And let's just go ahead and find s. So we're going to do sine of s on the other side of my proportion here. Sine of s, and we're going to put that over 6.1. We're going to cross multiply. Okay, so I cross multiplied. I'm going to have to divide both sides by 3. And then again, because I'm finding an angle, we're going to have to use the inverse sign. So we're going to do sine to the negative 1 of 6.1 times the sine of 28 divided by 3. So again, I would take 6.1, if you have a calculator, times the sine of 28 first. Divide that by 3, and then do your second sign so that you get your inverse. And either type in the rounded decimal, so like this one would round to 0.955. So I get 72.7. So that's going to round to 73. I'm going to round it up. So back over here, angle S is going to be 73 degrees. So then for T, because I know 2 of them now, I can easily find the third by just taking 180 and subtracting those 2 angles that I know, 28 and 73. And that's going to leave me with 79 for T.